It's just, I went for a run. So just in case you have any questions, you can actually go to the slider and post your question over there, okay? To know about it, we can be part of Okay, let's get started. Okay, so on the board is actually the again, this is actually the QR code for you to enter the Slido, so you can actually post your questions on the fly. Okay, and below this is actually the score distribution for your homework 1 and then the quiz 1. You can see majority of the student actually doing, I guess. So I say most of you is doing actually great. Okay, so let's actually average. Okay, so for homework 1, we got like 10.5 out of 12. Quiz 1 is actually roughly 5 out of 6. Okay, and I noticed there's actually still quite a few of students that you haven't actually participated actively to do your quiz and homework, and that is dangerous. Okay, the fact is that we have 3 midterms, 1 finals, right? Guess which one is actually the one that always give the lowest grade? First? No, first one is actually good. Okay, typical students actually do well in the first midterm. Second one is actually the one that's going to be very tough. Okay, so for the midterm one, typically the student can score something around, they say the average, just the average. Okay, the average is maybe around 70. Okay, midterm 2, 55. Okay, and then when we go back to the midterm 3 is the one that everybody do the best. Okay, maybe go to like 75. Okay, and final is totally different story because everybody have different schedule. So it fluctuates. It's hard to predict. Okay, so the best strategy for you to get a score that you want is actually you do really well for your midterm 1 and midterm 3. That's actually the one that's easier to get good scores. Okay. The content in midterm 1 is actually very simple. Okay. The worst thing you can do to yourself is actually you give up the opportunity to actually to score well in the very beginning. Okay, and this happened very easily because in the beginning of the semester, you are overwhelmed. You have too many things to do, and you don't have a good plan. Okay, so I think that's actually the main reason why students did not do well in the midterm 1. But once you did not do well in the midterm 1, when you hit midterm 2, and you see the grades actually so bad, right? You lost all of your confidence, right? Even though you maybe can come back a little bit on midterm 3, it's not going to give you the score that you want. Okay, so I would strongly encourage students that start early, okay, and then really practice early enough so you can actually really do well in your midterm 1, okay? And then we'll actually work on the midterm 2. Okay, we're going to do a lot of questions together with you, so you know you can do well in midterm 2 as well. Okay, the reason midterm 2 is actually difficult is simply because the calculation is actually more complicated. You need to actually memorize a lot more steps. Okay, but if you understand the principle, it should not too, it should be okay too. Okay, so you're going to see me post these things weekly. Okay, I'm going to tell you how we do. Okay, so I'm actually reaching out to the manager and trying to ask out what is the average score for the quiz and homework for the whole sections. We have 4 sections, I believe, for CHEM 1312. Okay, so I want to see how you do and compare to the overall population, so that you know where you stand. Okay. All right. So any questions for this? Okay, if not, let me see what other question we have on the Slido. Okay. And for the sake of time, only actually answer questions that was can upload. Otherwise, I spend too much time answering the questions. Okay. The first question is actually, do you have? I don't. Okay. So talking about this, if you haven't actually subscribed my channel, please do so. Okay. In order to actually for me to actually get some money to improve my hardwares and to have subscriber more than 1,000, which is incredibly difficult to obtain. Okay, so I think that's actually the answer to the first question. Can you explain calculation with density converting to molarity? Yes, I do. Okay, and then we are going to okay, so we're going to do that. Okay, we are going to talk about a collective property extensively today. Okay, we're going to go through at least 3 questions. Okay, so hopefully they will actually give you enough insight. What happens if you call on me randomly? I'm not there in the lecture. I'll just call another guy. Yeah, don't worry about it. Okay, so I hesitate to say this. Okay, on the syllabus, okay, it is mandatory that you actually attend the lectures in person, right? Yeah, but sometimes things happen. You need to actually go somewhere. You are going to miss the lecture. Okay, you don't need to email me. I don't take attendance. Okay, I consider you an adult. You know what is actually best for you. Okay, so you don't need to tell me what you're going to do. Okay, I respect you, your schedule. Okay, and then I trust you can do the best for your own future. So these things is actually just handle it yourself. Okay, the only thing I will say is that I found it's actually most effective if you actually participate the lecture in person, because when you come here, you actually focus a lot more about what I'm actually talking about. We post all the lectures on the Teams, right? So in principle, you can actually have access to all the contents. Okay. So if you feel like that's actually the best way for you, fine. Doesn't matter to me that much. Okay. So you don't have to actually email me saying, okay, you are going to miss these lectures. Okay. The things that you actually email me and discuss with me is that if you are going to miss your midterm, okay, there are only a few conditions you are allowed to miss your midterm and retake your midterm in some other time. Okay? And those situations was specifically actually described in your syllabus. You really need to use those reasons, okay, to make the case. And once you decide to skip the regular time for your midterms, you need to actually attach the corresponding documentations so that I can actually forward those information to the manager. Okay, and then you can actually retake the midterm in the later time. Okay, without documentation, there's nothing I can do. Okay, so make sure you know if there's such things you plan to do, then do it early, discuss with me, prepare the documents accordingly. All right? Okay, so I guess that's all the questions I need to answer for now. And then regarding to the unit conversions, where are you going to use density? Again, that's actually the main question that people want to know, right? So I would strongly suggest that you go to the this Hangout. This Hangout is actually shared on Teams too. It's actually chapter 10.1, concentration conversion. Okay, so the only time you will need to do you need to use the density is actually when you do the concentration conversion between molarity to molality. Okay. And here, I believe I write down every single step. Okay, so I would strongly suggest that if you still wonder when you will need to use the density, that is actually the case. So go back and check the hangout. Okay, then you should be able to figure out when you will need to use the density without being confused by the description inside the question. All right. Okay, I hope that's actually okay. All right, without further ado, we should actually get back to the things and talk about the collective properties. Oh, before we, okay, yes. So this is actually one of our main focus today. There are only 4 collective property. Okay, one is so-called the vapor pressure. One is called the boiling point, freezing point, osmotic pressure. These are the 4 collective properties. And each of them have the associated equation go with it. Okay, so those are the equations you need to actually memorize. The first thing I want to talk about is actually the vapor pressure. Okay, so the main concept here is that if you throw in more solute, okay, into your solution, the vapor pressure of your solution will become lower. Okay, so that is actually the concept that you should have for the first collective property. Okay, the higher the concentration, the lower the vapor pressure. Okay. If you want to really calculate the vapor pressure, then we use this equation, the Raoult's law equation, to calculate the vapor pressure. Okay, and it goes like this: the vapor pressure of your solution is going to equal to the mole fraction of your solvent, not solute. Okay, solvent multiply the vapor pressure of pure solvent. Okay, so why this is actually like that? Okay, you need to understand. When we talk about the vapor pressure of the solution, the contribution of the vapor pressure comes from what? Solvent or solute? Or both? Okay, so in this case, we talk about that your solute is non-volatile. So what does it mean by non-volatile? It doesn't evaporate. Okay. What is vapor pressure? Okay, so have you think about this? We talk about, you heard this term a lot, right? What is vapor pressure? So what is pressure? What's the definition of pressure? Okay, so the pressure, any of you is actually coming from physics? Okay, what's the definition of pressure? Okay, so it's actually unit weight per area, right? Yeah, so that's actually the unit of pressure, right? So how does vapor actually create pressure? You want to think about the things at the molecular level, okay? So inside air, what do we have? What are the molecules that we have in the air? Nitrogen, oxygen. So these are the main gases inside the air, right? Okay, so all these small molecules that diffuse in this free space, okay, and they are going to hit the surface of certain things, right? And once something click on the area, you generate the pressure. Okay, so the same thing, right? So in order to generate this gas molecule from the solution, okay, and we're supposed to talking about the contribution from the solutions, right? it has to come from the solution. It means actually the solution to actually produce some gas molecule. So you can actually hit the wall of your glass to generate the pressure. Okay, so what I say is actually, okay, I have a solution. I have a non-volatile solute and a solvent. Okay, solvent typically is actually volatile. In chapter 10, the most common solvent we use is water, right? So water in the liquid form will evaporate, become water gas, right? Or sometimes we call it steam. This steam molecule is going to hit the wall, produce the pressure. Okay? So right now, think about this. You're throwing a lot of non-volatile species into your solution, right? And all these species is going to prevent your molecule go to the surface and then become gas molecule. Therefore, since you now have less molecule coming from your solution into the free space, therefore the vapor pressure will become lower, right? The more you throw in the solute, the lower the vapor pressure it will be. Okay, so that's actually the principle why we say the higher the concentration of your solution, the lower the vapor pressure. Okay, make sense? Okay, so that's actually a very simple thought, but let's actually solve the issue here because that provides the correct or accurate molecular model for you to actually understand why that is actually the case. Okay, so with that being said, now you should also should be able to see that if today you have pure solvent, okay, if you did not throw in any solute into your solution, okay, if you just have pure solvent, you should have the highest vapor pressure, right? Okay, so if I have a pure, that means actually the mole fraction of my solvent is going to equals to 100%, right? So your mole fraction of your solvent equals to 1, right? And then if you throw in more solute, then the mole fraction of your solvent will what? Will decrease, right? Therefore, you know the vapor pressure will decrease as well. Okay, so that is actually why here you need to actually know the mole fraction is the mole fraction of your solvent. Okay, not solute, but solvent. Okay, so this is actually why you have this Raoult's law equations. Okay, and this is actually true when your solute is non-volatile. Okay, so most of the time, if you see in the question, it describes your solute as a solid. Okay, so solid has very, very minimum vapor pressure. Okay, so you consider all these solid solute going into waters, it is a non-volatile species. All right, and under the specific conditions, you know to calculate the vapor pressure, you use the Raoult's law of equation. Is that clear? Any questions for this? Okay, so if not, then we need to actually consider the other situation. So far we talked about the solute is actually non-volatile, right? Typically in the solid form. What happens if today your solute is actually in the liquid form? So if you see a solute in the liquid form, meaning that your solute is also volatile, right? So in this case, you need to use this equation, okay, to calculate the vapor pressure of your solution. E will be the sum of the mole fractions of your solvent or solute multiplied its corresponding vapor pressure in the pure state. Okay, so let's give you one example. If I have H2O and then ethanol, okay, both are in the liquid form at room temperature, right? So if I have a pure water, then I know I'm going to have the vapor pressure of pure water. Okay. Similarly, if you have pure ethanol, you are going to have its corresponding vapor pressure, right? So you see this little circle on the top right corner that indicates it's actually the pure substance. Okay, so these little circles indicates the pure substance. Okay, so in this case, if you want to calculate the vapor pressure of your solution, it will simply equals to the mole fraction of your H2O multiply H2O vapor pressure in the pure state plus the mole fraction of your ethanol times the vapor pressure of pure ethanol. Okay. So in this case, the important thing you need to see is that, okay, you need to identify, okay, what is your solvent, what is your solute first, right? And you need to actually recognize that in your solute is actually a volatile species. Typically, we can just see these things by recognize the phase of your solute. Okay, if your phase of your solute is in the solid form, it indicates it is a non-volatile species. However, if your solute is in the liquid form, it indicates your solute is also volatile. And in that specific case, this is actually the way you calculate the vapor pressure of your solution. All right? Any questions for that? Yes. You need a number or you don't know the meaning of that?
No, I don't. I know water was 23.9.
I don't know. Yeah, but if okay, so the key thing is actually you know how to calculate it. Okay, so if you want to ask you a question like this, you will. So you can see here how many unknown you have here. Yeah, 5 of them, right? So you have 1 unknown, 2, 3, 4, 5, right? However, you also know that the mole fraction of H2O plus the mole fraction of your ETOH has to equals to 1, right? Because inside your solution, you only have solvent and solute. Okay, and here we only talk about binary system. Okay, so you say you can have 4 unknown or 5 unknowns. Okay, if this is actually something they want to test you, they will give you the information of 4 variable and actually calculate the 5th one. Okay, so that is actually the type of questions you will be encountered if this is actually something they want to test you. Okay, the most important thing is actually, can you actually recognize your solute is volatile, right? Do you understand how to calculate the vapor pressure of a solution? So those are the key things that you need to actually know. All right. Okay, so let's actually all the things you need to know about for the vapor pressure. The next thing we want to talk about is actually the boiling point elevation. Okay, so in here we want to use this equation. Delta TB equals to I times KB times N of your solute. Okay. What is delta TB? The change of boiling point. Okay, compared to what?
Oil?
Yeah, what is this delta means?
Like for instance, if you had a delta T of 4, if your boiling point is 100 degrees, are we assuming that it's 104 degrees? It went up.
Very good. Okay, very good. So first thing you have to think about is actually boiling point. The boiling point of the solution will be dictated by A, solvent, B, solute. Solvent, right? Okay. All the property we'll talk about this collective property is actually all the property of solvent. Okay. So using water aqueous solution as an example. Okay. This delta TB meaning the change of the boiling point. Even we're going to say the boiling point of the solution is actually deviate from the boiling point of your solvent. Okay. So use water as example. You know the final boiling point is going to equals to the boiling point of your solvent plus delta TB. Okay. And delta TB can be calculated using this equation. Okay. So make sure you know this is actually a boiling point of your solvent. Okay. If you throw in your solute, the new boiling point of your solution will be the original boiling point of your solvent. This is actually very important. Plus then delta TB. E will only be plus. Okay, has to be plus, not minus. Okay. The reason is because we say for the molecule going from liquid form to the gas form, which is actually boiling process, right? It will actually go to your surface first. Okay, but then you actually throw in a lot of solute. Those solute will actually occupy the surface area, right? So you need to actually keep longer. Okay, what's going to reflect actually the temperature to go a little bit higher, so you can let the liquid form of the water molecule go into the gas form. Okay, therefore, if you throw in more, the boiling point of your solution will just increase. Okay, the degree of increase can be calculated using this delta TB equation. Delta TB can be calculated through this I times KB times M. What is I? Van Hoff coefficient or Van Hoff factors. Okay. What is KB? It is a constant. Okay. Depending on the solvent, the KB will change. Okay. What is M? The molality of your solution. Okay. So you can see that the delta TB is actually proportional to your concentration, right? Meaning the higher the concentration, the larger the temperature change will be, right? And then since this is always plus, right? So you know, if you add in more, if you have higher concentration solution, then the boiling point will become higher. Okay, it's very important that you memorize all the things. Okay. I want to talk a little bit about this I, the Van Hoff coefficient. Okay. You only see I when your solute belongs to three species. Okay. If you have acid, base, or soluble salt, then you can actually start to consider the Van Hoff factor I. Okay. For example, HCl is actually one of the most famous acid, right? Hydrochloric acid. Once you store it into water, it becomes H plus and then Cl minus. So you can see 1 mole of HCl molecule is going to produce 1 mole of proton H plus and 1 mole of Cl minus inside your aqueous solutions, right? In this case, your I is going to equals to 2, right? Because you can 1 mole of your reactant produce 2 moles of the species inside your solution. Okay. Similarly, the I of this base, sodium hydroxide. So in this case, I is also going to be equals to 2, right? Anyone have problem actually understand why I write 2 here? Okay, it's very important you understand these things, okay? The third one is actually salt. Okay, so when you see salt, you're going to see all different kinds of salt, okay? But let's look at some features, okay, you need to be actually able to recognize, okay? CaCl2, okay, this is actually a very standard salt, okay? Once it dissociates, what will it become? Ca 2 plus Cl 1 minus, right? So your I is equals to 3. Okay. How do you know CaCl2 it is a salt? Okay, I want to actually point this in. Yeah. So look at the periodic table. It's actually very important you see this. Okay. You see that 1A hydrogen starting from the lithium, sodium, potassium, RBCS and Fr, right? And then in the 2A, you have Be, Mg, Ca, Sr, Ba, and Ra, right? Once you see these 2 columns, okay, you know the first column will give you 1 plus. The second column is going to give you 2 plus. Okay. If you see these 2 columns, there's actually a very high chance you're actually having a salt. Okay. And most of the time, these 2 columns will actually work with the carbon 17. Okay. Carbon 17 is actually elements like to exist in the 1 minus form. Okay, so you can see the elements. The elements actually F, Cl, Br, I, and Ap, right? Yeah. So all of things want to actually exist in the 1 minus form. So if you see a compound, it's actually a combination of low things. For example, in this case, you have CaCl2, right? Because we know Ca want to exist in the 2 plus form, right? Cl want to exist in the 1 minus form. So this is actually 2 plus. This is actually 1 minus, right? Therefore, you need 2 Cl to compensate that 2 plus charge so that the overall species is neutral. Okay? But once you dissolve in the water, right? This charged species, they will actually separate from each other because they have water to surrounding land. So they feel comfortable. Okay, so let actually go back to the state they like the most. Okay, so in this case, I hope you should be able to write down this equation because only after you write down this equation, you can clearly see what I is, right? There are a few interesting anion ligands. Okay, for example, this one, Na3PO4. Okay. When you see this compound, the first thing that should come to your mind is that you see this Na, right? Na is what? 1A, right? So you know Na is actually 1 plus, right? And you need 3 of them to make the whole thing become neutral, right? That means your PO4 will be 3 minus, right? Therefore, you can actually write this. Okay, you know you can easily write this. And then your I will equals to 4. Okay? And so PO4 is actually a ligand. is so-called a complex anion ligand. Okay, it won't further dissociate. It's actually by itself, it's actually very stable. Okay, and then it like to exist in the 3- form. Okay, so this actually is something that you should have in mind. It's nothing special. Once you know it, and you can just remember it. Then you can actually use these things in the future. Another very important one is actually the okay. So once you see this, I hope you right now you should be able to see this one should be 2Na plus SO4 2 minus, and then the I is equal to 3. Okay, so every time you see the metals in the 1A or 2A with the first and second column, you should ring a bell. Okay, you should know that this most likely is a salt. Okay, and then based on the equation, trying to write out this, then you should be able to write out your I accordingly. Okay. Any questions for this? Okay, if not, I want to actually talk about one of the questions that I got from students. Okay, so this is actually one of the questions he encountered. It's actually a very similar concept here. In which solvent the following substance dissolve to generate greatest extent? H2O or the CaH18. Okay, for this species. When you see this species, you need to actually recognize what it is, right? LIF. Okay, so it's Li and F, right? What is Li? 1A group, right? F is actually the 17. So you know Li want to exist in 1 plus, right? And F want to exist in 1 minus. So apparently, this is a ionic species, right? This is a salt. Okay, the salt like to dissolve in water. That's actually why the answer is actually water. Okay, so like I say, there are 3 species like to dissolve in water, right? Acid, base, or salt, right? How do you know you have a salt? A soluble salt will always contain either 1A, 2A elements, plus with either halide or the rho right next to it. Okay, so that's actually how you know how you actually make the selection. Okay, because once you have that concept, this question is actually so simple, right? Because you know, okay, I have 1A. I have 1A elements. Okay, 99.99% of time has to be water. Okay, so those are the simple concepts that you know. Once you know it, you'll realize many questions is actually so easy to answer. Okay. All right, get back to here. So now I hope by now you have a good idea about how to write it little I. Okay. K is just a constant. Okay. N is actually the molality, which you should know how to calculate by now, right? Yeah. So let's actually the second one, okay, the boiling point elevation, okay, meaning the higher the concentration, the higher the boiling point it will be. Okay. Next one. Freezing point depression. Okay. What it means is actually if the higher the concentration, the lower the freezing point will be. Okay. You can calculate the change of your freezing point through a very similar equation. Delta TF is equal to I times the constant KF times the concentration of your solution. Okay, so in this case, you know the final freezing point should be the freezing point of your solvent minus delta TF. Okay, it has to be minus. Okay. The very last one is actually the osmotic pressure, where we're going to use this equation pi equals to I times m times T. Pi is the osmotic pressure, right? What's the unit of that? ATM. Okay, so it's actually very important, you know. Yeah. I have to have the unit of ATM. Okay. I again is actually a bank of factors. What is M? Molarity. Okay. It is not the molarity we use for the boiling point or freezing point. Okay. In this case, it's actually the molarity. Okay. What's R? What's the value you should use? Okay, it's very important. 0.082, not 8.314. Okay. If you look at the constant, okay. If you look at the constant, and then if you look at the unit, this has unit of liter times atm per mole per K. Okay, so in order to do the calculation right, make sure you use the right constant. Okay. The very last term T is the temperature, right? The temperature has the unit of Kelvin, not degree C. Okay. So what this says is that if you have higher concentration for your solution, then the osmotic pressure will become higher. All right. So those are pretty much the concept that you should have for the collective property. Okay. Before we actually jump into the calculations, okay, we want to refresh our memory again. Okay. So think about this. All this full property is actually dictated by the property of your solvent, right? Now your solution is actually mainly coming from your solvent. Okay. The higher the concentration for your solution, your vapor pressure will become lower. Okay. It's very important. You need to actually follow this thought. Okay. The higher the concentration, the lower the vapor pressure. Okay. The higher the concentration, the higher the boiling point. Okay. The higher the concentration, the lower the freezing point. The last one is the higher the concentration, the higher the osmotic pressure. Okay, so those are the concepts that you should have before we actually jump into the questions. Okay. So let's look at the question number 8. All right, so look at these questions. Consider the solution where you have 0.04 m urea, 0.04 m AgNO3, 0.04 m CaCO2, which has first the highest osmotic pressure, second the highest vapor pressure, third the highest boiling point. Okay, so how do you actually solve this problem? Again, first you need to identify the keywords, right? What are the keywords here? Osmotic pressure, vapor pressure, boiling point. Okay, so before we come to this page, remember how we say? If you have high concentration solution, your vapor pressure will be lower, right? Your boiling point will be higher, right? Your freezing point will be lower, right? Your osmotic pressure will become higher. Right? So far so good. Okay, so you want to know, you have three different kind of solution. One is 0.04 m urea, and then 0.04 m AgNO3, 0.04 m CaCl2. Okay, so here on the surface, you can see that the molality is actually all the same, right? Okay. So one very important thing for the collective property is that the Van Hoff factors need to be taken into account as well, right? So let me write down this so you have some reference. Okay, so the P solution, if you have a non-volatile species, right? These are the actually four main equations for the collective property, right? So right now, the things it says is apparently in terms of concentration, they all look the same, right? So what will be actually the main thing that's going to dictate all this change? It will be actually your Van Hoff coefficient, right? Everybody follow this logic? Yeah, make sure you actually can see this, okay, because you're going to see so many this kind of questions in your homework and the quiz. Okay, so now you also need to figure out what is actually I here. Okay. First one, what's the I? The first one is actually urea, right? Does it look like a strong acid? It's confusing, right? Okay, so I'll tell you, we're going to learn this later, okay? There's only 7 strong acid. Only 7. Okay, name a few. Hydrochloric acid, sulfuric acid.
Acetic. Oh, wait, no, that was the nitric acid.
Okay, yes, nitric acid. Okay. Good, you already know 3, right? So I'm going to tell you all the remaining ones, okay? But all those acids has a very distinct feature, is that you're going to see H in the very beginning. And then typically associated with always hetero group. Okay, meaning is HI, HBr, H is all the color. Okay, it must have the oxygen or the halide. They will become a strong acid. Okay. Strong base has to be a very clear OH associated with either 1A or 2A group. Okay, for example, sodium hydroxide, calcium hydroxide, okay, or the MgOH, okay, either 1A or 2A group associated with hydroxides, then they will become a strong base. Okay. That's how you actually distinguish whether you have a strong acid or strong acid base. It's actually very simple. Okay, the feature you're looking for is actually H associated with some halide or associated with oxygen. Okay, that's how you identify do you have a strong acid. Okay. Strong base is actually you must have 1A or 2A group associated with OH. Very simple, right? Okay. The very last one is what? The salt, right? The salt you must exist in either 1A or 2A group members. Okay, if you don't have that, it's not a soluble salt. All right. So with that being said, let's come back and see these things. The first one. Do you see 1A, 2A group member over there? Do you see sodium, potassium, or calcium, magnesium? You don't, right? You see a bunch of NCOH, right? So it is actually an organic compound. So when you have organic compound, what does it mean? It doesn't dissociate. Okay, so once it dissolves, it stays the same. Therefore, the I is going to equal to 1. Okay, so the way you actually solve this is actually really looking for, okay, do you have this 1A or 2A group? That will be the easiest way. Okay, if you do have it, okay, you either have strong base or you have a soluble salt. Okay, so you know for this guy, the I is equals to 1. How about this guy? CaCl2. Ca is 2A, right? Cl is actually the halide group, right? So you know CaCl2 is a salt, right? What will be the I for that? 3, right? Because it dissolves, once it dissociates, it becomes Ca2 plus 2Cl minus, right? Therefore, you know the I is equals to 3, right? Okay, now we need to, any questions for this? Okay, then come back to the second one, right? AgNO3. Okay, remember previously I said there's a few complex anion. Okay, NO3, SO4, PO4. Those are the 3 major ones. Okay, so let me rewrite here. Okay. Okay, so these are the soluble anion. Okay, so if you see a compound contain this species, it's going to dissociate. Okay, so these 3 will be actually the mostly commonly seen 3. Okay, and those are the 3 you're going to see a lot in your homework. Okay, so you actually have a sense. Okay, if you see SO4 2 minus, PO4 3 minus, NO3 minus, you'd have some sense. Okay, they are going to dissociate. Okay, so with that being said, then AgNO3, you know it's going to dissociate, right? That means you are going to have Ag1 plus, right? Plus NO3 minus, so you neutralize, right? So this one will become Ag plus NO3 minus. Therefore, your I is going to equals to 2, right? Okay, so far so good. Okay, so with that being said, the I is equals to 1 for your urea. I is equals to 2 for your AgNO3. I is equals to 3 for your calcium chloride. Right? So even though they have the same molality, but if you consider the I, the effective concentration will be 0.04 m. This will be 0.08 m. This will be 0.12 m. You see the differences now? They are testing whether you know what is the actual effective concentration of all these 3 different species. Okay, and once you know that, the next thing is actually going to you're going to use this one to predict the change for those collective property, right? The first one is what? You want to find out the solution has the osmotic pressure, right? And we just say if you have higher concentration, your osmotic pressure will become higher, right? Therefore, in this case, we are looking for the one that have the highest effective concentration, right? Therefore, for the first one, you know this will be your CaCO2. Okay? The second one, the highest vapor pressure. We just say if the concentration of your solution become higher, the vapor pressure will become lower, right? But here is actually looking for the high vapor pressure. That means you want to select the solution with lowest concentration, right? Therefore, in this case, you know, this will be your urea. Okay? The very last one, the one with high boiling point. Okay? And we mentioned that if you increase the concentration of your solution, the boiling point will increase, right? So here you want to find out the highest one. Therefore, you're actually looking for the solution with highest effective concentration, right? Therefore, you know the answer will be CaCl2 again. Okay. So, any questions for this? Okay. Let's recap the concept we have went through. This type of questions actually test out you two things. The first thing is actually, can you properly write out the Van Hoff coefficient of each solution? Okay, so let's actually prove into that you really need to know how to do it. All right. Once you know the Van Hoff coefficient, then you can actually know what is actually effective concentration of the species, right? So let's actually step number one. You also need to have an ability to recognize what is actually your strong acid, what is actually your strong base, what is electrolyte, right? And then the tips that I give you is that, okay, looking for the elements in 1A or 2A, right? Because if you see the element in 1A and 2A, most likely it belongs to a base or a soluble electrolyte, a soluble salt, sorry. Okay, and those things will actually just dissociate. Okay, and then you should also really write these three things down because you are going to see this complex anion all the time. Because once you identify those species, you know it belongs to a salt. It will dissociate. Okay. If it actually doesn't belong to these two groups, you know it most likely is a organic compound. The I is going to equals to 1. All right. So let's actually the first layer of knowledge that you should have. Okay. And after that is actually you need to know the collective property, right? The higher the concentration of your solution, you're going to have lower vapor pressure, higher boiling point, lower freezing point, and higher osmotic pressure. Okay, and that's actually all the things you need to know to answer this question properly. Okay, so this is actually questions many students feel so confused in the very beginning. Okay, but if you can see those important connections, if you know all these simple tips, it becomes a questions that you can always get a full credit. All right, any questions for this? Okay, so if not, let's look at the question number 9. Okay, so calculate the boiling point in degree C of a solution made by dissolving 3 grams of ethylene glycol in 10 grams of water. The KBP of the solvent is 0.512 K per molality, and the normal boiling point is 373 K. What are the keywords? Boiling point, right? Once you see boiling point, collective property. Once you see boiling point, collective property. Once you see vapor pressure, collective property. Once you see osmotic pressure, collective property. Okay, so those keywords allow you to actually quickly come into the associated equation that you want to use, right? And then the equation you want to use is actually very simple. Delta TB is I times K times your molality. And then you know the TB final is going to equal to your TB of your solvent plus or minus. Plus, right? Because boiling point always increase, right? Plus your delta TB. Right, so these are the two things that once you see this keyword boiling point, write down these two equations. Okay. After that, you want to know what other things that you have. You have this, right? The KBP is given to you, right? 0.522K. Okay, and then the normal boiling point 373K is this guy, right? So this is 0.512 K per M. This is 373 K. All right. What else do you have? Okay, you have 3 grams of your solute, right? Your solute is what? Ethylene glycol, HOC2H4OH. Okay, so what is this species? Is it a strong acid or strong base or a salt? Okay, is it a strong base? It is not, right? Do you see 1A or 2A group members? You don't, right? So it cannot be a strong acid. It cannot be a strong base. It cannot be a soluble salt. Okay. Do you see just H? So here actually require you have some CHEM1312 knowledge, right? Okay. It actually give you the name of the chemical, right? Ethylene glycol. Okay. Does it actually say it is an acid? It doesn't, right? Does it sound like an acid to you? It is not, right? It's actually a strong acid. Those acids you actually heard of it. Okay, so you know it's not a strong acid. It is not a strong base. It is not a salt. Therefore, organic compound, right? What's the I? One. See, easy, right? So you know your I is equals to 1. Okay, so come back here. You know this is going to equals to just 1, right? So you know, if you look at the first equation, you know your I, you know your K. Do you know your M? Okay, you can find it out, right? Because it gives you what? It's 3 grams, right? So you can calculate the number of mole of your ethylene glycol, right? Let me call EG. It's going to equals to 3 grams over the molecular weight, which you can calculate, I assume, using the periodic table, right? Therefore, you know the number of mole of your solute, right? Do you have the weight of your solvent? right? 10 grams of water, right? And therefore, you know, you can compute the M, which is going to equals to moles of your ethylene glycol divided by the weight of your H2O in kilogram, right? So by doing that, you can actually figure out what this is, right? So you know your I, you know your K, you know your N. Therefore, you can compute your delta TB, right? You can calculate this guy, right? Since all these three is actually known. Everybody follow? Okay, so once you know your delta TB, you can compute your TB final, right? Because you know your TB solvent is 373 K. This one can be obtained from here. Therefore, you can know your TB final in Kelvin, right? And then you go from here to make it in degree C. So let's say actually the logical flow how you solve this problem. Okay. So up to this point, there are a few things you should be actually very good at now. And that thing is actually the definition of the concentration terms. Okay, because if you don't know really well for your concentration definition, here you are going to get stuck. This part, right? You will get stuck if you don't know the definition of your concentration term. Here you're going to get stuck. Because you get stuck here, you got nothing for this specific questions. Okay, so really memorize the definition of each concentration terms. It's very essential. Okay. And then by now you should also see that the lecture is designed in a way that you need to keep using the things you have learned, right? And then you keep using it. Okay, and this is going to repeat over and over again in the future too. Okay, so let's actually how you do question number 9. Okay, I'm going to skip number 10. I want to talk about number 11. Okay, so when 3 grams of a protein were dissolved in 50 ml of solution at 27 degrees C, the osmotic pressure was found to be 800 torr. Calculate the molecular mass of the protein. Okay, what is the keyword here? Okay, osmotic pressure. Osmotic pressure tell you it is a selective property, right? And then you know the equation is that is actually equation you need to use, right? Okay, so once you write out this equation, what are the things that you know from the question? Okay, so here it says your osmotic pressure is 800 torr, right? But we keep emphasizing this one. Okay, when you talk about the osmotic pressure, what's the unit of the osmotic pressure? ATM, right? Do you know how to convert the unit from torr to ATM? Divided by 760, right? So you know the pi is going to equals to 800 divided by 760, right? So you know you have your pi. Do you know your I? What is your I? 1, right? How do you know it's actually 1? It's protein. Yeah, protein by itself is actually organic stuff. Right? So like I say, only when you have strong acid, strong base, or soluble salt, then your I will not become 1. Okay, but here it's a protein, right? A protein just a series of carbons, right? Oxygens, nitrogens. Okay, so it is not a strong acid, it's not a strong base, it is not a soluble salt. Therefore, your I is going to equals to just 1, right? Okay, I'll put M here for now. What is your R? 0.082, right? What is your T? 27 degrees C, right? Which is how many K? 300 K, right? So what is the actual only thing that you don't know? M, right? So you can actually calculate your M, right? M is going to equals to 800 over 760 divided by 0.082 multiply 300, right? So you can actually calculate your M. Okay, but is N the things that the question is asking for? It's not, right? What is it asking for? The molecular weight of your protein, right? So what do? Again, you come back to the definition of your M again, right? So what is the definition of your M? This is actually your molarity, right? Which is actually, on the numerator will be moles of your protein, right? Divided by the volume of your solution in liters. Okay, so if you look at the questions, the volume of your solution is what? 50 ml, right? Which is going to equals to 50 divided by 1,000, then many liter, right? How do you define moles of your protein? Will be gram of your protein over the molecular weight of your protein, right? What is the gram of protein that you have? 3 gram, right? So you know it's 3 gram over the molecular weight you want to have, right? Therefore, this whole term is going to equal to that number. Okay, so the only unknown here will be just your molecular weight. Okay, so by solving the equation, you can get the information of molecular weight. Okay, any questions for this? Okay, so I want to recap the idea again here. First is again looking for what? Keywords, right? So in today's lectures, 4 keywords: vapor pressure, boiling point, freezing point, osmotic pressure. So these are the 4 keywords today, right? And then you have to associate equations that you actually memorize. Okay. You also need to have a clear understanding of the definition of different concentration terms. Sometimes we have molarity, sometimes we have molarity. Okay. And then you also know that mole is calculated by the mass of your substance over its corresponding molecular weight. Okay, and that's all the things you need to know to solve actually all the questions we're talking about today. It's actually very simple. All right, so that's actually what you should actually learn for chapter 10. Okay, I'm going to use the very last 5 minutes to go through a very simple concept for chapter 11. Okay. So chapter 11 is going to start to learn about the kinetics of reaction. What is kinetics? Yeah, kinetics. So what does it mean though? You heard this term every time, right? So, okay, so a very general broad definition of kinetics is that you want to know the change of a certain species over a period of time, right? So the change of, for example, change of concentration over a certain period of time. Those are the things we want to talk about in chapter 11. Okay, so when we talk about the change of concentration over time, we typically referring to the reaction rate. Okay, so if you look at one equation, chemical equation, where you have AA plus BB that give you CC plus DE, right? This capital A and B, we call it as reactant, right? And then C and D, we call it as product. what is that small, the lowercase a, b, c, d? Anyone know? Stoichiometry chemistry coefficient, right? So when we learn about rate, okay, you can actually monitor the change of A, change of B, change of C, and change of D, okay? Then we can write out something like this. Right? The change of concentration of A over a period of time, delta T, right? So this term is so-called the consumption rate of A, right? How about this? Consumption rate of B, right? How about C? How about this? Now you're not concerned. You actually produce it, right? So it's actually production rate of C and production rate of D, right? So you can see from our simple description, you know, one is actually disappearing, one is actually appearing, right? That's why for the disappearing one, you know the rate will be actually become, that term will become negative, right? So when we talk about rate, the rate is always a positive number. That's why we put a negative sign in the front. Okay. Okay. The other thing we do here is what? Do you see this little guy here? You do some normalization. Okay. So the reason for this is because if you have A plus 2B, that give you AB2. For example, let's actually the equation that you're going to see. Okay. In order to produce one of your product, you do consume 1 mole of A, 2 mole of B, right? So the consumption rate of A and B is not the same. Okay, because you disappear 1 of A, at the same time you actually disappear 2 of B, right? So if you just calculate your A over time or B over time, they won't be the same. But you want to actually know the overall reaction rate, right? That's why we actually need to normalize those coefficients. Okay, so that we can get this overall reaction rate. Okay, so this is actually the overall reaction rate. Okay, it has to be normalized by the coefficient. Okay, so these things alone actually create some confusion. When you read the question, okay, it can just ask you, okay, I want to know the consumption rate of A. Okay, so in that specific case, what the question wants to know is actually delta A over T. Okay, but it can also say, okay, I want to know the overall reaction rate of this specific reaction, okay? Then since right now I want to know the consumption rate of the overall reaction, then you need to do delta A over delta T divided by your coefficient A, multiply a negative number. Okay. Everybody still with me or you got lost? Okay. Consumption rate of A, you're going to calculate using what? Delta A, delta T, right? But if today you have a reaction, it's actually AA plus BB, that give you CC plus ED. If I want to know the reaction rate, then there will be you get it now? Okay, so depending on how you word it, it's actually going to ask you different quantity. Yes. Yes. This lowercase a is actually a coefficient in front of the species in the chemical equation. Okay, so you need to be very careful. Okay, so these are actually things you probably actually encounter in your homework. Okay, so you want to actually pay close attention. Is it actually asking for a specific species or the overall reaction? Because the calculation will be different. Okay, one, you need to actually take into account the coefficient in front of the chemical species. All right, so I will stop here, and then we'll talk about this differential and integrated rate law next week.